Okay, so thank you so much. Welcome back to our next video. So for today, we'll be going to deal with regards to the deletion operation already in the graph data structures, the same thing. So in this, let's actually move on to the next problem, which is the adjacency list, the same thing, using the adjacency list and removing a specific edge in terms of between vertices. So that means to say between the current between the vertices that you do have. So you will just only remove a path, a certain path. Now, so for adjacency list, to delete the edge between U and V, and where U is your edge and V, I don't know, this is U and this is V. For example, use adjacency list is traversed until V is found and it is removed. So if that I and J, for example, if they are adjacent, so therefore you will just remove that in a list, and of course you will update as well in your in your list structures that you do have. So let's try to figure out how does it work for the edge deletion in terms of undirected graph using the adjacency list. Now, suppose that you do have here using this kind of graph, the same thing. You do have A to E graph and you want to remove path directly for B to D. If that path is existing, so if that exists, you will just automatically remove that in your graph. And of course, in your adjacency list, make sure that you was able to also get the adjacency list for this one, since we are using the adjacency list. So if you don't know the adjacency list structure, that was also in the previous video. And for this one, this is the adjacency list of this particular graph. And for that particular graph, you want to remove the BD or the DB path. So since that is here, so BD, you will automatically remove that. And since B is adjacent to D, so therefore you will remove D here. And since in your D, that is adjacent to B, so you will remove B here. So their adjacent to B will become AE, and for adjacent of D will become ACE. So let's try to check that. And you already removed the path of BD and DB here. And your insert for your adjacency list, it will be updated as what I mentioned earlier, that it will become AE, and you remove here the D. And in your D, you remove the B and it will become ACE. So that's how you will work on with the adjacency list insertion, deletion. That is not insertion anymore. I'm so sorry. That is deletion. So let me update that one. I'm so sorry. It was so bad. So that is deletion rather. Okay. So thank you so much. That will be for the deletion of the vertex in terms of the edge deletion in terms of the undirected graph. So let's proceed with the edge deletion in terms of the directed graph. So suppose that we do have here a graph, something like this. So it will be deletion of a specific path in terms of this one here. Remove path from A to B. So is there a path for A to B? So let's try to check that one, A to B. So there is a path present in your graph. So therefore, we will be going to remove that one. And of course, make sure that you was able to get the adjacency list for that one. So for the adjacency list, that was also posted in the previous video for the directed graph. And for removing the path A and B, you just remove that in here and you will just update from A only, since A is only adjacent to B and B is not adjacent to A. So A, you have here the B and you will just remove B and it will become C right now. Retain the C and remove only B, and in your B, it's not the A is not adjacent since that is directed graph. So suppose that you already removed the path of A to B. Now, as I mentioned, you will have to update your adjacency list right now, that you just only remove those adjacency that you remove in that certain path. So that's how you do the deletion of the edge in terms of using the adjacency list. So in the next video, I will be going to also discuss in terms of the edge removal or deletion in terms of using I mean, using the adjacency matrix. So see you there.